Epik Mellon podcast, conversations with the real humans behind broadband networks, cybersecurity, and the future of communications. Brought to you by QA Cafe.
Hello, everyone, and welcome to yet another episode of the Epik Mellon podcast. I'm your host, Jason Walls from QA Cafe, and I have with me one of my heroes, one of the heroes of the way that everything works. And you don't know, and it's like I was telling you, like I'm trying to like the show is trying to humanize the people behind the internet and how it works, right?
Yeah.
And there are pieces in play that I don't think people understand are solely responsible for a lot of things even working at all, right? And I feel like, Ethereal and Wireshark are like it's like a huge, it's like almost like if you were to think of like four pillars holding up the way everything works, it's absolutely is one of them. But before I go into what all that is about, I just wanted to say thank you for coming on, because Gerald Combs is basically the inventor of Wireshark. And if you haven't heard of Wireshark, then we're going to explain all of that and all of how that works. But it's very cool to have him on right now. As always, this podcast is brought to you by my employers at QA Cafe, and as such, the views expressed by myself or Gerald do not reflect those of QA Cafe or in its ownership, which allows us to say whatever we want. And it is brought to you by our three great products. First of all, being CD Router, the industry standard test platform for broadband gateways, Wi-Fi devices, and other customer premises equipment with thousands of pre-built test cases so that you don't have to do any of that work, while it sits and automates itself and integrates with your CI/CD system, helping you build better products overall. And second and thirdly is CloudShark Enterprise, which is basically it's presenting Wireshark to you in a way that's a little bit more easily consumable to a large scale enterprise. And we've worked pretty closely, back and forth with the open source community on that, and it's great. It's like I say, CloudShark Enterprise is great, but it's great for the UI reasons and the API reasons and those kinds of things. But really, ultimately, it's Wireshark behind the scenes. And on the other side of that is Packet Viewer, which is also allowing you to put Wireshark into your web-based, cloud-managed networking or cybersecurity apps, letting you get all that cool functionality and all the stuff that Gerald and their team works on in a way that can be easily consumable into a web app. And that's my spiel. All right. So, yeah, thank you for coming.
Well, thanks for the kind introduction. That was nice.
Yeah, sometimes I have kind of a game show host voice, right? But like, I really do mean those things, because you and I have probably never ever talked in depth. We've probably talked just a couple times, but like my background, even though I do marketing and I do this show, my background started at, the University of New Hampshire Interoperability Laboratory. And I started using Ethereal when it was Ethereal. And not just as Ethereal, but also, in tandem with a lot of unique and weird packet capture devices that we had for a lot of different use cases back when things were very hardware dependent and, very use case specific and all that, but being able to look at the packet captures, and I've talked about this on the show with a number of guests, being able to look at the packet captures teaches you more about how protocols work than anything you could possibly do. Anything, right? Like you have to look at them and see the conversation flows and understand all of the headers and all that stuff. And when you see it for real, then it's much easier to understand how networking protocols work.
Well, yeah, I mean, it sounds like we had similar starts. I got my start, in the network industry. When I was attending University, UMKC, University of Missouri at Kansas City, and I was working at the university. I was working my way through school, and I was working in the computing services department.
Cool, yeah.
And they would send me around campus with this thing called a sniffer. It was a pretty hefty device, but it was the state of the art at the time, made by a company called Network General. And I've actually met the founders of Network General, in more recent years, and they're wonderful people. But at the time, it was this box that cost about as much as a luxury car. And as you said, we had all sorts of different networking technologies. So this thing had 10 meg Ethernet, it had FDDI, and it had token.
Oh man,
and
token ring.
Yeah, and so I would just go plug it in, go around campus, plugging it in occasionally, and trying to help my managers troubleshoot the network whenever we had issues. And that was my very first introduction to, okay, here are the packets going across the network. Here's how you can go dig it down and look at them. And then later on, I got a job at a small ISP in Kansas City, and we couldn't afford a sniffer because they, I think I mentioned, they cost about as much as a luxury car. They were kind of pricey. And this is back in the 90s, and the thing to know is that in the beginning of the 90s, I think Sniffer or Network General got their start in the 80s. But if you wanted to build a protocol analyzer back then, you had to get a bunch of money, hire a bunch of people, put them in the same room, and say, okay, write dissectors or decoders for all these different protocols.
For this protocol, right?
Yeah. But the industry had changed by the time the late 90s came around, and you could, computers were faster. You could, get a laptop with 10 or 100 meg and then capture a reasonable amount of traffic with it. You could develop software remotely. So by the time, I needed a protocol analyzer at the small ISP and they couldn't afford one, I thought, fine, I'll write one. And I came up with this minimum viable protocol analyzer called Ethereal. It's what we called it originally, and I released it as open source because I'd used open source quite a bit at that time, and I started immediately getting contributions from around the world. And your team probably knows this. The Wireshark isn't written by me; it's written by about 2,300 people, and I'm just one of them. And and the cool thing is, somebody I know mentioned that Wireshark is the perfect open source project because you can have all these experts around the world developing protocol dissectors for Wireshark at the same time, because nowadays we just write software in distributed fashion. It's the way we do things now.
Right, and that absolutely would like the it's particular to the case of networking and network protocols that something of that magnitude wouldn't happen without that. Right, like it would be impossible to expect. I'm thinking about it even now for some of the protocols that I work on through the standards meetings that I go to. Right, it's like no one, there's no one out there that is going to write USP protobuf dissectors for me.
But the way protocols are developed is it's much more distributed now. You don't have somebody like Novell going and developing their own protocol, a whole protocol stack. I mean, Network was its own stack, and it was developed because they hired a team of people to sit in a room and do that. At least that's how I envision it. But you just don't do it that way anymore. Everything is done remotely and distributed, and it was interesting to me, at least talking to the people who founded Network General, just talking about just seeing how they had to develop things in their environment versus how things happened in my particular environment. And there were only a few years between those environments. Just seeing how things change so rapidly. I do have a relic of the time. I have.
Yes.
I mentioned that I started getting contributions from people around the world. Well, back then, this was before places like GitHub or GitLab or even SourceForge existed. And so you had to host everything yourself. And I hosted everything myself on this. This is Sun SparkStation IPX. It has I think 64 megs of RAM, megs, not gigs, 48 megahertz, not gigahertz processor, and a disk. And I was, as modest as that is, I was able to throw a whole bunch of software on it and be able to host our project, and that's where it lived for a long time.
Out of curiosity, like back then, how did version control work? Like how did that collaborative work even get done? Or was it all you just being like
let's see, initially it was our version control system was me. It was people sending packages to Gerald. I would apply them to the source code and just cut off, just make these releases, and that didn't work. My wife, and that didn't work because my wife and I, shortly after I did the release of Ethereal, my wife and I bought a house, needed a lot of work, and suddenly I was doing all this remodeling and not applying patches. And one of the developers tracked down my phone number and called me up and said, "Hey, you're going to support this project anymore?" And that was a wake up call because I knew I needed to support the project, and that's kind of what I've been committed to ever since then. But that's when I set up, back then it was called CVS, concurrent versioning system.
Yeah.
Then sometime later we went to Subversion, SVN, and then later on to Git, which is where we are now. But yeah, it's tracking the history of our source code is
but what's great about that is
yeah.
people think that I'm actually joking when I say that there are parts of the way that the internet work, or the way that the way that global computer networking is able to operate. There are parts of it that were reliant on people having a single computer in their basement, like one guy having a thing. And I'm like, no, I'm not kidding.
Well, I mean, there's still, I don't remember about that off the top of my head, but there are still projects out there that, like, especially some of the old GNU projects that still manage that way. You just send them a patch and they'll kind of integrate everything and then throw a tarball over the wall, and that's how you get your release. But
right.
But the standard today is just to have your source code managed using Git, and probably a GitHub, maybe a GitLab.
Yep. And I mean, it's 1,000 times easier. And I like how it has kind of changed the mindset too, because open source as a concept has been around for a long time.
Yeah.
But it has evolved to the point where it's a little bit easier, right? And there's goods and bads to that. We've experienced a lot of situations where, and I don't know if this is kind of the same, where it's like, and actually, maybe this is actually a great example of it being the other way, right? With Wireshark and having 2,300 people working on it. But there's a lot of other open source that's out there where people are just sort of sitting around waiting for somebody else to do the work,
Yeah. Well, I mean, we're very fortunate in a lot of ways.
Right.
I mean, a lot of open source projects. I mean, there's this XKCD comic where it has this stack of blocks, and at the very bottom, holding everything up, it says there's this one guy in Nebraska maintaining this open source project. And no, it's true, and it is an actual problem in the open source community and the world at large. We have all these trillion-dollar companies depending ultimately on these little teeny projects that are just one person often.
Right. It's like, what happens when that guy buys a house and has to do housework? Like,
exactly. So I can't stress enough how fortunate both Wireshark and I have been over the years, because I've been paid to work on Wireshark and Ethereal pretty much since their inceptions, and that's a rare thing in open source.
No, it is, but it goes to show how important it is, and how important the companies that you've worked for, right, that indirectly, who are basically funding you so that you can do this, like, they all recognize what this is. And the community is actually pretty tight, right? Like, and the Wireshark Foundation is really great.
Yeah. Since you bring that up, the Wireshark Foundation is, I like to refer to it as a sinister plot to help me sleep better at night. For the majority of the project, or for the majority of the lifetime of the project, we basically, whoever I worked for was the primary sponsor of Wireshark or Ethereal, and that was great. That along with that, we mentioned GitHub before. GitHub lets you manage source code really easily. GitHub doesn't let you talk to a lawyer.
Right.
Sometimes you need to do that, and so that's what I relied on, my employer for. If I needed to, the big thing was, like, getting a code signing certificate. It sounds easy, but you have to jump through like a dozen hoops, and it's a lot easier if you just get a company lawyer to say, hey, this guy is trying to get a cert on behalf of this project, give it to him, and then suddenly the problem is a lot easier. And anytime you need to come up with an agreement, like for trademarks or getting trademarks registered, or accounting stuff, my employer whoever I worked for at the time was happy to take care of that. But that's a single point of failure.
Right.
And also, I was a single point of failure. I ended up being the only person working on the project who was able to do things legally on behalf of the project. That's not a good place to be. And so we talked about the issue for a long time, and ultimately arrived at the decision to start just to create a nonprofit foundation. So we incorporated the Wireshark Foundation a couple years ago and spun it up in earnest in, let's say, the beginning of 2023. And that's, when you download Wireshark, the Wireshark Foundation is who is paying for that infrastructure. If you go to SharkFest, the Wireshark Foundation is hosting that conference. If you, do anything Wireshark related, the Wireshark Foundation is taking care of that. And so now part of my job is to go convince people to give the Wireshark Foundation money so that we can actually exist. So I've traded
I
one
never
worry.
asked to be in sales.
Yeah, exactly. I've kind of traded one worry for another, but it's a good trade. I do know that if I needed to step away from the project for any length of time, that there are people there now that will do a great job, and B are legally able to do that. So
Right.
I do sleep better now because of that.
Yeah, and it's like I don't want to sound like I'm overstating the importance of it, but like it's something that Chris Greer says a lot about how at the end of the day, all of the stuff that is underpinning any of your ability to fix any problems on networks is you going into Wireshark, right? Like it will be eventually, right? But there is, there's not a lot of packet capture experts out there, at least not visible on the surface, right? And so it's good to have that community be a little bit more visible now,
Yeah. And one of the things I love about the project is that we've established this baseline. If you want to go analyze packets, you can do that using a really good tool, and you can do it for free. And that's something that didn't exist years ago, and so I'm really happy with how that turned out.
Yeah.
But you mentioned people maybe not knowing about Wireshark. I do know that it's used quite a bit in education. I mean, my dad mentioned, he lives in a small town outside of Kansas City, and mentioned that the high school there uses Wireshark to teach their networking class. So
good.
just
Good.
Yeah.
No, it's super important. It's like I said, I don't you can't learn networking without it, because you can't understand it until you really look at the reality of these things that are happening, and it makes it that much cooler, right? Like the light bulb going off in people's heads, and this, because back I worked for the interoperability lab as a student and as staff, and when we're making like our regular, because we had pretty high turnover because it was all students, and so basically we had to plan every 4 years of having those people rotate out and having good enough training for the people that were just coming in, right? And watching, because you'd see these people who had already been exposed to networking or not, and seeing the things actually happen, you could see like the light bulbs going off in their head, and it just makes it like 1,000 times more accessible, the concepts themselves. Yeah, it's been very cool. So, and then when did the name change? When did
that was
Ethereal
in
turn into Wireshark?
2006. The name changed because Windows XP was not very good at capturing wireless. Early on in the project, when I first developed it, I only used Linux and Solaris, and maybe classic Mac. I didn't really pay attention to the Windows side of things, and I got away with not using Windows for much longer than I should have been able to. But I did that first release, and Ethereal ran on Linux and a bunch of Unixes, and I was actually pretty happy with that. But there were a couple of grad students in Italy, Loris Dejani and Gianluca Verni, who developed WinPCAP, which was a packet capture driver.
Oh yeah.
That let you, if you used libpcap or if you had an application that used libpcap, you could port it over to Windows very easily then with WinPCAP. This little driver that they developed kind of revolutionized things. And some of the Wireshark Ethereal developers back then ported Ethereal over to Windows, and suddenly we had this huge user community. And in the early 2000s, and then at the same time, 802.11 was just came on the scene, was getting really popular. But the thing about about that time was 802.11, although it was popular, it was not stable, it was not secure, and So you needed to
Nope.
do a lot of troubleshooting, a lot of hands-on look at the packets
Oh,
going over there.
back then you had to do a
Yeah.
lot of troubleshooting on wireless. Yeah.
Well, now too, but
We're
I'm
all
trying.
employed here
Yeah, yeah.
because of wireless.
I'm trying to be kind here, but but yeah. But at the same time, we had all these users who were using it through on Windows, doing a great, doing it very successfully. But if you wanted to capture wireless on Windows XP, as soon as you put it into promiscuous mode, the driver did exactly what you didn't want it to do, which was it kind of shut things down and didn't give you any packets at all. It just shut down the networking adapter. So we got a lot of complaints, and so I sent Loris and John Luca an email saying, can we fix this? And by that time, they had, as a bit of foreshadowing, they started a company here in Davis, California, where I now live. But we sent some emails back and forth, and they said, yeah, sure, we can develop a driver and just use an off-the-shelf adapter and capture packets that way, using this special driver we developed. And so, and at the same time, the company offered me a job, so I moved from Kansas City here to California with my wife and my daughter. But my former employer owned the trademark for Ethereal, and for whatever reason, we just
Oh,
couldn't. They're nice people. We just couldn't come to an agreement to transfer it over. And so, we came up with a list of candidate names. I showed it to my wife. She said Wireshark, and so that's why you're using Wireshark.
that's awesome.
I like to joke that
What were some of the other options?
I don't remember the serious ones. I do remember one of my friends was really pushing for Ether Weasel, but
I would go with a long, glorious tradition of naming software projects after rodents. So, like,
yeah. I mean, if you want to call something Ether Weasel, I'm not going to stop you, but we got Wireshark. I'm happy with that.
no, it's good.
No,
It's good.
but I joke that my wife is our style consultant, but anytime anything comes up, like, we're developing a logo or we're doing this and we need to pick a color, she's just has this innate talent for just zooming in on what is the best, just what is viscerally and subconsciously the best way to
Cool.
present something. So
No, and I mean,
yeah,
honestly, from a branding perspective, there's all sorts of side benefits now, right? Because, like, the um, we do- Shark Fest, right? You end up
yeah,
accidentally piggybacking on the hashtags of Discovery Channel, right? Which I always love because
yeah,
every year it's like the same. It's around like similar times, and it's like, yes.
yep,
Um,
uh,
so my first Shark Fest. So again, so the fact that something like Shark Fest even exists is awesome
yeah,
too, right? And like, um, you get the people, and from what I hear, like there's been a good sort of cadre of newbies every single time, right? Like new people coming
yeah.
in, especially to Shark Fest, right? And so you have the people like yourself and a lot of the trainers that come in, the regular people in the community, giving these talks, but there is actually a pipeline of new people coming in and learning all this stuff, which is very cool.
Yeah, and that's something we try to focus on and try to find ways to attract meet people new to the industry. We have, if you're not familiar with SharkFest, it's our developer. The official name is the Wireshark Developer and User Conference because it started out as this way to bring the core, just the development team together to meet. But the idea,
Right.
immediately we knew that, okay, if we're going to have the developers come, we should have the users come too. And so, it's this event that we've hosted since, what is it, 2010, 2008, for a long time. But we get everybody together. We have pre-conference classes. So if you are new to the industry, or if you just want to kind of spackle and fill in your gaps, you can go to these pre-conference classes and kind of get up to speed
Hmm,
on
hmm.
protocol analysis. And then we have the rest of the conference where we have sessions on a whole bunch of different stuff, from advanced analysis to the decryption to wireless to uh, to development. It just all sorts of different things, and the content's changed, with each conference, and I, at least from my perspective, it's a worthwhile thing. And we typically have a U.S. conference and around June-ish, and then a European conference in the fall. This year, the next SharkFest is going to be in Richmond, Virginia. Vint Cerf is going to show up.
I saw that, and I was like, oh, now I have, like, I really want to.
I mean,
and actually reading about that, and just like reminding myself of the timeline of various things in internet technology. That, like, going back to what you're saying about how the first version of Ethereal, was even, you were sniffing Token Ring too. Like, I always forget that things like TCP/IP were older, or at least parallel to a lot of things that were pre-Ethernet, even though now the rest of them are gone, right? And that's very weird, because you think about, right, if you think about the higher layers of networking having been there that long, as the really, really clunky stuff that we had to sort of figure out which things worked and which things didn't, right?
Yeah. I mean, it's whenever Vint has showed up to a couple of SharkFests in the past, and each time, I just go into full fanboy mode and just kind of lose it. And just because, okay, here's the person that looked at what we had before circuit switch networking, and thought, okay, that's a really not so efficient way to move information over the network. Let's break it up into little teeny packets. And suddenly, that little idea of, hey, if we break things up into little packets, suddenly you can get a lot more information on the network and do a lot of different cool things with it. That little bit of insight has changed our world.
And they held on to it as long as they could with ATM, but
Oh yeah.
No, it's definitely, and it's so the ubiquitousness and the interoperability of it is obviously what allows everything to be what it is today. What we have talked a lot about on the show sometimes is that, especially with Wi-Fi, is that as good as those technologies are and were, like, they are not necessarily that great for all use cases. And so you have a lot of the world now of old technologies that have, as everything has tried to go IP, right, that you're like, oh wait, now we have to, like, refix a problem that that was done on purpose for TCP/IP, right? Which is really funny. It's like, broadcast television and all these things. It's like, it's almost like, like, wait a minute, didn't we already solve this problem? Like, but it works. It works, and it's great. Talking about fanboying, though, when I went to my first SharkFest was 2012, I think. And it's when Cliff Stoll was there, and he did his speech. Yeah. And I had no idea that he had been involved in any of that. I had just read his book when I was a CS student. So I was like, wait, really? This guy's like my hero. The music definitely got me into networking.
Oh, cool.
Not Leyden jars, though, or whatever he does now. Not Leyden jars, whatever those weird. I forget what they're called.
Well, yeah, the 3D version of a Mobius strip.
Yeah.
A Klein bottle.
Klein bottle, that's what they're called. Yeah. Cool. Yeah, no. So it's very cool to see this journey sort of happen, and like I said, like, be responsible for so much stuff actually working that I don't think people, I don't think people understand. Not that they don't understand Wireshark or don't understand packet captures, but understanding just how insanely rudimentary it is to everything,
Yeah, well, I mean, I like to say that the networks don't stay fast, reliable, and secure by themselves. That takes a lot of effort.
Right.
And the thing that people don't realize is that they degrade over time. That just because software ages out, technologies move on, you run out of bandwidth, the equipment just kind of ages out and fails, and sometimes it fails gradually instead of all at once, and just there are all sorts of things that
Entropy always wins. Yeah.
yeah.
Yeah. Yeah, it's true. And that it's the same with just the rudimentary technologies as it is with with anything else. But I mean, we there's tons of situations like that, especially like you know some of those proprietary protocols that are still around, right?
Yeah.
Things that Nortel invented or Cisco invented, right? They're still out there, right?
Yeah.
What's that running the Simpsons episode where it's like traveling through the internet and at one point it goes through a dryer tube into a Cisco router and then it's like that stuff is real. It's
Yeah.
real. um, yeah. So I mean, what do you think now? I've talked I talked to Chris a little bit about this. I've talked to a couple other people about the future of that knowledge, and with everything working with AI and feeding packet captures into that, and just making sure that that people are constantly aware of this, and that it does underlie everything, and it is something that you need in your expertise set in order to be good at doing your job,
Yeah.
and just making sure that those people, that pipeline is always being filled. I don't know what your thoughts on that are. I know what some of mine are, but
um I I should have more to say about AI than I do, but I know it's there. I know that it has great potential, and I know people are working on using AI to analyze packets. As I understand it, you have more success if you apply your model to something very specific, like a telephony stack, or some very very industry specific stack, like maybe IoT or something like that. That at least today's models work better with that versus having some sort of everything model that can just analyze any traffic. I
right,
mean,
right,
we're not there yet. We may never get there, but
right.
I've kind of my work lately has been focused on the other end of that, kind of expanding what our dissection engine can give you.
Hmm.
Um, at the when people look at Wireshark, they look at this list of packets and what the UI gives you. When I look at Wireshark, I look at what's behind it, which is this a dissection engine. It's something that takes this raw blob of bytes and breaks it down into all its constituent fields and tells you as much about each of those fields as it can. That's where
Hmm.
Wireshark
Hmm.
gets its power.
Hmm.
And we support, I think, 265,000 fields across 3,000 protocols now, and that those numbers, that's where that indicates the vastness of what you can do with it. But the thing that I'm working on in my day job and that I've been focusing on is a sibling application to Wireshark called StratoShark, which
Yeah, I did want to talk about that because it's very
okay,
cool. Yeah.
but it does for networking. StratoShark does for system calls what Wireshark does for networking,
Right.
and log messages as well. So um, if you look at your computer, you have your operating system, and you have all the programs running on top of the operating system, and there's this layer that sits kind of between them, where at least I call the system call layer, where if your application wants to do anything interesting or useful, like read a file or connect to the network or show you a video or play audio, it has to go through that system call interface. And so I had a frog in my throat, sorry.
It's all good.
So it so when your programs want to do anything useful, they go through that interface. And if you look at that layer from a networking perspective, it looks like a network segment, and there's all
Yeah.
this useful information passing through. And if we can tap into that, you can get useful information. And I mentioned Laurie Stejani, one of the authors of WinPCAP before. Well, he started a company called Sysdig and wrote an open source tool called Sysdig, which lets you
Ah,
capture system calls. And so now we have this rich source of data. We have this little CLI tool called Sysdig, which lets you kind of look at these system calls using kind of like TCP dump does. Sysdig the company has also developed an open source tool called Falco, which works a lot like an IDS, except it runs under host and looks at system calls. And if anything odd is happening, it will
Oh,
send you
that's
an
cool.
alert. Yeah. And Stratashark kind of fills in the rest of that sort of suite with this interactive forensic analysis tool that will let you look at a system call capture and kind of dig in and see what these programs are doing.
Cool. And has the format for that been standardized? Like, obviously, it's different depending on the operating system, but like the format of the thing that Sysdig is consuming to do what it does. Is there a PCAP, right? Is there a PCAP NG of the right?
Well, since you bring that up, I mean, if you look at libpcap, there's this whole ecosystem built around it. You have TCP dump. libpcap is a packet capture library, but it also has a file format, like you said. You have TCP dump, you have Wireshark, you have Snort, you have Zeek and Nmap, and all these other tools that kind of use libpcap and either analyze or send packets or whatever. And in later years, we've developed a file format called pcapng, which is an extended form of that file format. And pcapng lets you, pull in stuff from multiple interfaces. It lets you pull in stuff that aren't necessarily packets. I know Mike Kershaw, the author of Kismet, has pulled in, I think, geolocation information. And one of the things he's working on right now, just because he can, is environmental radiation, which you can also stuff into pcapng.
No, that's cool.
No, but people are finding all these sources of data and stuffing them into pcapng. And one of those sources is system calls and log messages. If you look at the file format that Sysdig and Falco and Stratashark use, it's pcapng. It's just that capture doesn't have any packets. It just has system calls.
Okay. Cool. That was it's like great job, past selves.
Yeah. I need to find the date, but I think the pcapng itself, I think, is coming up on its 20th anniversary.
Yeah.
It's wild. It's I don't see it in my calendar anywhere, but yeah, it's been around a while, and people have found all these different uses for it.
That's really cool. So that's actually so nice that it's basically the same thing.
Yeah. The next question is, well, can you mix, system calls and logs and packets and all this stuff? And in theory, yeah, you can. The trick is displaying it in a way that's useful.
Right.
At least, with Wireshark's interface, you have this fixed set of columns, and if we don't really have a good way to, when you jump from a packet to a system call, to suddenly switch to a different set of columns and show you things that are relevant to that item.
Yeah. No, exactly. And being able to, at least at a manual level, be able to make some correlative observations and stuff like that. That'd be very cool. But the pieces are all there, which is what's cool.
Oh yeah. Right? And I'm sure the day's coming. So
yeah. No, that's awesome. Oh, that's exciting. But yeah, I'm glad for this. I'm glad for all this. It's like I said, it's like the thing. This Wireshark indirectly is the thing that got me excited about networking. It really is, right?
Thanks.
Because I am a very visual, hands-on learner, right? And if it wasn't for the fact that there was a way to look at this stuff, then I would never, it's all just in your imagination otherwise. And I made that joke about ATM, but it was the same way, right?
Well, yeah. Well, I mean, if you looked at an ATM capture, I don't know that I have any actually, but
no, that was one of the weird boxes that I used to have to deal with. Right, it was just like fiber on both sides, and it was like, this is an ATM packet analyzer.
So, for the people who aren't familiar, one of the and I forget how they arrived at the number, but ATM packetizes things, but it breaks them down into these really tiny packets called cells that are only like 53 bytes long.
Yep.
So if you're worried about Ethernet 1500 bytes not being big enough, and you're looking at jumbo frames, ATM goes in the exact opposite direction. And for especially in the modern era, you look at it and you think, why would they do this? I mean,
why would they do that? And when you started to I remember Like it's, when you were doing the calculation of just how much overhead was being used up, it's like,
Yeah.
yeah,
Well, I mean, even it was originally developed to transfer voice, but even then, why not make it a K, 1,000 bytes or something useful?
right.
Who knows?
And for those know, so for those catching up to speed, ATM was asynchronous transfer mode, right? So it
Yeah.
was, it was, it was, it was meant to preserve that circuit-based switching model a little bit longer.
Yeah. But didn't a whole bunch of switches use ATM on their backplane forever?
Mm-hmm. Mm-hmm.
I mean, I can't
Yeah.
remember what like the 6500 did, but I do know there were switch models out there that I was looking at the feature set and said, we have an ATM backplane. And I'm thinking, why?
The nightmares that keep me up at night was PPPoEOA.
Yeah.
Like, why? It was good times.
Yeah.
But um, it's not like that stuff is over with either. So like new protocols are coming out all the time, right?
Yeah.
You would think that we've learned our lessons, but we haven't, right? And it's that other XKCD comic about the 14 different standards, and we need one
Yeah. Yeah.
standard and so you have 15 different standards. Like
Yeah,
that still
exactly.
happens with protocols. And a lot of them, interestingly enough, a lot of them do start off as proprietary ones, and then they end up getting standardized through ITF, right? So,
Yeah.
um, not Jabber, whatever became XMP,
XMPP? Yeah. Yeah.
XMPP, right? And then MDNS was just Bonjour, right? And
Yeah.
that was an Apple thing. And then Quick, right?
Yeah.
Yeah, Quick was Google being like, TCP sucks and we want to change it. And they were like, yeah, okay.
Okay.
So hold on. And so they did. And now it's becoming an issue.
Well, and the cool thing about on the Wireshark side, seeing that develop is a lot of times when, especially larger protocols are being developed, people will add support for each draft revision of that protocol, like
Oh,
draft spec
wow.
1, 2, 3, 4, 5. So I don't know if it's still there, but at one time you could kind of go choose between different draft specifications of the
Oh,
quick.
that's good though, because I suppose
Uh,
you have to, right?
yeah,
Because if you're going to actually be trying to do this stuff pragmatically, like you have to be able to do that while it's being developed.
yeah,
Like,
yeah. Um,
yeah.
and I do know that, like iSCSI, when it was being developed, we had that little selector for the different standards. I don't know if we still have that, but no, if you're developing a product that implements this protocol, you have to be able to analyze it, and you have to be able to do interop testing and conformance testing and things like
Hmm,
that.
hmm,
So,
hmm, hmm.
this is where that kind of comes in.
And the earlier you do it, the better.
Yeah.
Otherwise, you end up getting IPv6. But I'm kidding, Tim. It's
Well, I
it's
mean,
a
when
it's a running gag. When you were talking
yeah,
about people sitting in a room and making a protocol, like
yeah.
that is kind of what happened with V6.
Yeah, it's when I see people talking about IPv6 adoption and saying, well, I think we're up to 50% in the US now. But the thing is, people don't mention that. Okay, that's probably a lot higher percentage in people's households because your DSL or your cable provider is going to give you dual stack nowadays.
Right, right.
And I think that gap where people haven't adopted it are more in corporate environments, and so we're kind of seeing this bifurcation happen there.
Well, no, it's that's the reality of what you end up experiencing, seeing these protocols being developed is that
Yeah,
like being on the bleeding edge is a little weird because some of this stuff can stay around for 50 years
yeah,
because the total cost of ownership of them changing everything out and re-educating every people is like,
yeah.
no, we're not going to do that. Oh, and by the way, so that we don't have to do it even longer, can you add this and this and this to the current spec?
Yeah.
Can you add this band-aid on top of this band-aid? And there Wireshark is being like, yeah,
Yeah.
whatever you want, man.
Yeah. Okay. Another option header.
Yes,
Add that to the sector. We're done.
so true. 14 layers of NAT later.
Yeah.
Yeah, cool. No, it's very sobering. It's sobering, and I really appreciate it, and I really appreciate you and all that you guys do for what's happening, because this wouldn't exist, and things wouldn't, like, the internet wouldn't work. It wouldn't work without it. We would be stuck. We'd be stuck without Wireshark.
Oh, thanks.
So, it's very serious. Um, so yeah, I'd love to always talk about this. So definitely thank you for coming on, and we uh, we could talk for hours about all sorts of little intricacies about this, I'm sure.
Well, thanks. It was great being here.
Yeah, no, definitely. Yeah, so please do the usual YouTube stuff. Hit subscribe. I know many people know Gerald, and if you want to start some conversations with him on the YouTube channel, please do in the comments below. And above all, this is a perfect example. My closing line of this show is a perfect example of what happens when you do what I'm about to say. Like, Wireshark is the perfect example of this. Own the nerdy things that you love and have fun doing them. Thanks, Gerald.
Thanks.